Algebra 2, lesson 44 is all about solving right triangles. So I have a few blanks to fill in here, and then we're going to do a few samples. Sine, cosine, and tangent are ratios. They're just ratios of sides of a right triangle. And because they are ratios, they are always the same for any given angle. It doesn't matter how big the triangle is, how long the sides are. If you're talking about a 30-degree angle, the trig functions are the same every time. So the sine of 30 degrees is 1/2, no matter how long the sides of your triangle are. You know, similar triangles have congruent, like the corresponding angles are congruent. Anyway, so since these ratios depend only on the size of the angle, and do not depend on the size of the sides of the triangle, do not depend, I should have had you write not, on the size of the sides of the triangle, we can use them to find we can use these ratios to find missing parts of right triangles. Okay, any right triangle. In the future, we will want more precise answers than we'll be doing here, but we're just going to focus on the process now. So we will be rounding, and just a general rule of thumb, if you're not told how many decimal places you should provide, then it should be 2. All right, so let's look at example 1. We're supposed to find the missing parts of this triangle. Okay, quickest thing is going to be B, because we know every triangle, the 3 angles add up to 180. This one's 90, so these two have to total 90, which means 90 minus 24 gives us B, which I could have done on a calculator, but here we are. Okay, so that is B. B is 66. I do not need to write 66 degrees. The degree symbol is here. That'd be like saying 66 degrees. Anyway, that's that. Then we need to find the lengths of 2 of these sides, because they're also missing. And I don't know, I guess we'll find Y first. And you always want to use as much as possible the numbers you've been given. If I had made a mistake subtracting, then I don't want to use B. And even more so whenever we get Y, we don't want to use Y to get H, because we've rounded already, and then that'll make H off more. Anyway, so if I'm going to use this angle, and I'm looking for Y, which is the opposite side, and I have 9.5 here, which is adjacent to this angle, because it's next to it and not the hypotenuse. Opposite over adjacent is tangent. So the tangent of 24 degrees is the opposite, which is Y, over adjacent, which is 9.5. Okay, so now I've written that, and now this is just an equation I need to solve. Back to normal algebra. I need to get that Y by itself, so I would multiply both sides by 9.5, and now Y is by itself. So this is what I do on my calculator. And on some calculators, you need to put things in differently, but ours are pretty nice. We literally just type it in like this. It's 9.5 times the tangent of 24, and as long as you're in degree mode, you don't have to worry about degree symbol or anything. And then you hit equals, and I'm getting 4.2296 and some more stuff. We're, again, giving our answer for now in 2 decimal places, which means Y equals 4.23. Because the 9 tells me to round that second 2 up. So here's B, here's Y, and then we just need H. Now what I was saying before, I don't want to use Y because that's rounded to get H. So I'm going to use the 9.5 again. So now I have adjacent and hypotenuse. So that is cosine. The cosine of 24 degrees is adjacent, 9.5, over hypotenuse, which is the h. And now the variable is in the denominator, so I can't just divide both sides by 9.5 because that would give me 1 divided by h. I'm just going to cross multiply. Okay, so we have h times the cosine of 24 degrees equals 1 times 9.5, so 9.5. And then to get h by itself, I would divide by the cosine of 24 degrees. And whatever I do to one side of the equation, I do to the other. And now that's what I'm doing on my calculator. So we have 9.5 divided by cosine 24 equals, and I'm getting 10.399 and some other stuff. So h, I guess I should have said approximately for y, sorry about that. H is approximately 10.40. Okay, and we'll do a couple of others, but well, the next one's very similar. So, again, let's find b first. So 90 minus 35. See, sometimes it's quicker to do it on paper. I was using my calculator and I missed a button. Okay, so that would be b is 55. Okay, and then, I guess let's find m next. So m is adjacent to the 35-degree angle, and we have the hypotenuse. Adjacent over hypotenuse is cosine. The cosine of 35 degrees is adjacent over hypotenuse, m over 14. And now the variable's in the numerator, so I can just multiply both sides by 14 to get m by itself. So on the calculator, 14 times cosine 35 and that's 11.47 when we round. M 11.47. Okay, and then we need to find x, which is the opposite side. So now we're doing opposite over hypotenuse, which is sine. So the sine of 35 degrees is x over 14. And again, the variable is in the numerator, so I can just multiply both sides by 14. So now to find x, it's 14 times the sine of 35. Okay, 14 times the sine of 35. I'm getting 8.03. So x is approximately equal to 8.03. And something I forgot to mention on the first example, but I'll mention now, is we want to make sure our answers make sense. Because if you did happen to hit a wrong button, and you're not thinking about things, you might give a wrong answer that you would have known better. For instance, on the first example here, h is the hypotenuse. That needs to be the longest side. That needs to be longer than 9.5 and longer than what we got for y. Also, since 24 is the smallest angle, y has to be the smallest side. It had to be also less than 9.5, and it is. On this example, 14 is the longest side. If I get something larger than 14 for m or x, I know something's wrong. The hypotenuse is always the longest side. And the shortest side is always opposite the smallest angle. So x has to be less than m. And it is. Our answers are reasonable. They make sense. Okay, on to example 3. This one's slightly different because they didn't give us either of those acute angles. So we have to do something a little bit different for this one. Also, we're going to use the Pythagorean theorem to find x because, like I said, we don't want to use what we get for the angles because what if we made a mistake, and also we'll be rounding. and I want to use the numbers they gave me to find as much as possible. So we're using the 7 and the 6 to find x, which means 6 squared plus x squared equals 7 squared. All right, so we have 36 plus x squared equals 49. We'll subtract 36 from both sides. So x squared is 13. Yeah, 13. So x is the square root of 13. And since all these other things are being rounded decimals, I guess this might as well also, although this is the exact answer for x. The square root of 13, according to my calculator, is approximately 3.61. So x equals the square root of 13. It's approximately 3.61. Okay, now we still need to find both of these angles, and we'll need to use trigonometry to find one of them. And I think I'll find A first. And I know that the cosine of A, I want to use adjacent and hypotenuse, that's cosine. The cosine of A, degrees, is adjacent over hypotenuse, 6 over 7. And so we use an inverse function to find the angle. We use the trig functions when we have, like when we're looking for a missing part of the ratio and we have the angle. When we have the entire ratio but we're looking for the angle, we do kind of the opposite of that, the inverse function. So a way of writing the inverse function for cosine is that. That's not cosine to the negative 1. Okay, it's just what the symbol for it looks like. There's another way of writing it also, but this is what you're going to see on your calculator. So the cosine, the inverse cosine of 6/7 will tell us A. So on our calculator, to get this symbol, you'll see that above the cosine button. And to get those things, you hit the second button. See, it's the same color as the writing above your button. So you hit, on the calculator, you do second cosine, and now you should see cosine to the negative 1 with the opening parentheses, and then we put 6 divided by 7, and that equals approximately, A is approximately 31, I'm going to write 0.00 so I know I did my decimal places. That 2 just, we round down. So that's what I get for A. And now I could go through that process again, but using inverse sign to get B, but we can just subtract from 90 because A and B have to add up to 90. So when we subtract from 90, we're getting 59. So B, and that was based on a rounded answer, so that's approximately 59 degrees. But again, I'm not writing the degree symbol, it's already in the diagram there. And that's the end. Enjoy these things. I know I do.